folks, I think I shortchanged it a little bit on the last video to help with logarithms. Those 3 hints will work great with a bunch of problems, but I didn't address finding the vertical asymptote, and I really should address finding the vertical asymptote. So I've got another example here for you, log base 3 of negative x plus 3. So first, let's talk about vertical asymptote, and then we'll talk about those 3 different hints that I gave to help you graph logarithmic functions in Newton Alta. So how do you find a vertical asymptote for a logarithm? Well, remember just the basic logarithm, just basic y equals log, let's say base 2 of x. The vertical asymptote is right here. It is the y-axis, which is x is equal to 0. Why? Because if I substitute 0 into a logarithm, I get undefined. Now we could talk about y. Remember, we can change this to exponential form. 2 to the answer to the logarithm is equal to the argument. What do we plug in here for y to do 2 to the y equals 0? Not a thing. There's no way you're ever going to get 0 when you raise 2 to some kind of power. Okay? It's impossible. So this is a no solution, which means this is undefined. Now how does that extend to other problems? Well, to find a vertical asymptote, what you do is you set the argument of the logarithm equal to 0. What do I mean by argument? Just the inside. So whatever's inside the logarithm, which is negative x in this particular case, equal to 0, and solve for x. So here we go. If I set negative x equal to 0, I want to solve that equation. Well, you know, to solve for x, you've got to get rid of that negative in front of it. So let's divide both sides by negative 1. The negatives cancel, and that gives me x equals 0. That is my vertical asymptote. Now, I'm not going to do this other problem, but just picture, for example, if we had the function, look, way down here lower left, f of x is equal to log base, we could do 3 again, it doesn't matter, of x plus 2 plus 5. Now again, if I asked you to find the vertical asymptote, I set the inside of the logarithm, not the plus 5, whatever's in the parentheses of your logarithm, I set that equal to 0, and I solve for x. So I have to subtract 2, and I would get the vertical asymptote of x equals negative 2. So ignore the green, that's just an extra example thrown there at you. Our vertical asymptote is x equals 0. So what would we do? I can't manipulate this graph because it's just a screenshot, but I would slide this dashed vertical line living over here at 2 back over here to 0. That's the first thing. So notice it says graph the function by moving the vertical asymptote and the key point. So move the vertical asymptote first. Then we will plot a key point. Now, again, what are key points? Well, let's stick to those same 3 hints that I threw out there in the previous video. So remember what they are. Let me go to another page to describe the hints, and I want to rewrite this problem too. So log base 3 of negative x plus 3 is our problem. Now hint number 1 that I gave, and I need to restate this to make it a little bit more clear. I said plug in 1, okay, but here's the problem with that. If I plug in 1 right here, that's going to give me negative 1. So plug in so that the inside is equal to 1. So let's say that clear. And that's my bad because I was looking at a more basic problem. But if they give you something other than just plain old x inside here, then if you plug in 1, it might not work out. Like in this case, that would give me log base 3 of negative 1. And we know we can't take the logarithm of a negative number. So plug in so that the inside is equal to 1. Look, that would put negative 1. Look, if I plug in x is equal to negative 1, then watch this. I would be evaluating f of negative 1 equals log base 3 of a negative 1 plus 3. Okay, well, what does that give me? That's log base 3 of 1 plus 3. Now, we know that log base 3 of 1 is 0 plus 3, and my answer is 3. So that's going to be the point negative 1, 3. Now, if you only have to plot one extra point, there you go. There's an extra point. But now hint number 2, and again, I oversimplified this because I showed you a function that was way more basic than this. I said plug in so that, I said plug in the base. Well, y'all, if I plug in the base, I'm going to get log base 3 of negative 3. So I should say plug in, instead of saying the base, so that the inside is equal to the base. Got me? Just like it's equal to 1. So what would I need to plug in for x to make the whole inside equal to 3? Negative 3, right? So it would be x equals negative 3. So let's evaluate. I'm going to do it in red so you can see it clearly. F of negative 3 equals log base 3 of a negative 3, okay, plus 3. Don't leave out that plus 3 at the end. That equals log base 3. Now, two negatives make positive plus 3. Now, why did I do that? Because we know that log base 3 of 3 is 1 anytime the base and the argument match. So that's my goal. I want to make the argument equal to 1 for the first hint, and I want to make the argument equal to the base for the second hint. So that's going to be 1 plus 3 equals 4. If I plot them, that's a y value. If I plot that point, it would be negative 3, comma 4. All right, now I want to take a look at that graph, and so I'm going to try to pull up Newton Alta so you can see that problem in Newton Alta, and we will look at the graph of this. If I can't find the problem in Newton Alta, we won't be able to look at the graph, but again, real quick, just in case the video ends right now, I've got the point negative 1, 3. So here's negative 1, 1, 2, 3. That's that point. And then the other point, negative 3, 4. Okay, so negative 3 up here at 4. Now remember our vertical asymptote, we found it on the previous page, is x equals 0. And so I can already tell from there my graph is going to look very similar to that. Now what we didn't find was the x-intercept because we haven't learned how to find that yet. Okay, but we will have some time coming up soon at the very last section that we cover where we can do that. Okay, so I hope that helps. If I can pull this up in Newton Alta, you'll see me continue. If not, then it ends right here. Here we go. I was able to pull up the same problem in Newton Alta. So log base 3 of negative x plus 3. Remember, we found the vertical asymptote by setting the inside equal to 0. So when I set negative x equal to 0, divide both sides by negative 1, I get x equals 0. So watch, the first thing I'm going to do is slide this vertical asymptote, if it'll let me. So I'm struggling to actually get it to do. There it goes. And that's a pen thing, not a Newton thing. Okay, so I slid over my vertical asymptote, and then I'm supposed to plot one other point. Remember, I had a couple. I had negative 1, 3, or negative 3, 4. Now I'm going to plot one of them, but you better be sure I'm going to check the other one to make sure it's on the graph. So negative 1, this needs to go up to 3. There we go. And then the other one is negative 3. Look, it's up here at 4, so I feel confident that this is right. And then I'm going to scroll down and check it, just because it always makes me feel better to check it. So I'm going to push submit. Yay, and we got it right, okay, because you can always read the explanation. So I hope that clears things up. I shortchanged you on the first video by giving you just an oversimplified problem. If you have just plain old x inside, see, we have a negative x, but if you have a plain old x inside, then plugging in 1 and plugging in the base is a good idea, unless you have a fraction for a base, and then you would need to plug in the reciprocal. But if you have something else other than x in here, then make the inside equal to 1. So whatever x requires to plug in to make the inside equal to 1, next time make the inside equal to the base, as long as the base is not a fraction, and then you would have that third hint to deal with. And also, we talked about vertical asymptote, set the inside equal to 0. Hope this helps out a lot. If not, please send me your questions. I'll be glad to handle them one at a time. Have a wonderful day.